As I told you in the beginning, this is the very fundamental lecture which we are going to conduct today. There are certain basic topics or basic concepts which are needed to be received well. These fundamental topics now include that what is the completely random? What is the totally randomness of the event? And the second fundamental topic, which is every time or most oftenly used in the derivation, in the analytical as well as mathematical discussions, is the probability of new arrival in the duration t or in the time interval t. So these two topics, which are frequently used to justify the discussions of other important and fundamental topics, such as the role and application of the exponential distribution, such as the discussion of the pure birth model, pure death model, and later the generalized Poisson queuing system or queuing models, and later which is specialized or particularized as a particular queuing models. So these discussions will very frequently involve the concepts like total randomness, the elapsed time, and the probability of no arrival of the customers during the time interval t. So therefore, though I have already discussed this very topic few days back, but since later when we started mathematical discussions and we started dwelling upon the rigorous mathematical and analytical discussions, then later I felt that most of you are not receiving well about these discussions. Then we revisited myself and I am trying to make it more clear by giving the examples, and therefore you are seeing the handwritten PDF, not any book or such things, but the lectures which we are giving, I would like to mention once more, and you should also mention when you record any lecture on the YouTube or any multimedia that you have to very heartfully, very mindfully mention the references and references consulted during the study of these lectures. So naturally, we are for a long time studying the several standard literature on the queuing system, on the queuing theory, as well as the operational research. So I would like to mention once again the standard literature like Taha, the Salty is the very standard book on the queues, Clear Salty, and the Wagner is the principle of the operational research, is very standard book. And a Koff and Sesame is the very fundamental books, fundamentals of the operational research. And naturally, your favorite and familiar book written by the Indian authors like P.K. Gupta, Kanti Swarup, P.K. Gupta, and Manmohan, popularly known as Gupta and Manmohan. So these books, Kanti Swarup and Manmohan, so these books are the fundamental books which we can consult apart from other references or other textbooks. So out of the cultivation of the knowledge acquired over years, and after consulting these books, whatever knowledge we deliver to the others is the product of these cultivation. So today I would like to clear. You are getting the voice?
Yes, sir.
Okay. Okay, so today I would like to clear something, though this is very interesting, but though they are supposed to be very small, but very fundamental, we can say. Small, but very, very fundamental. These are the foundation stones of the edifice or the building of the given theory. So total random of arrival here we are talking about. Total random of arrivals. Total random of arrivals means here arrival you can put it is event. Here we are discussing in connection with giving theory, and therefore the event arrival is very important for us. So here we can say this is any event. We can apply this very concept to any area where we can apply this concept, the concept of the total randomness. This concept of the total randomness of the event is a fundamental issue. So how we define it? It is completely random because it is the assumption one the fundamentally laid down or primarily laid down assumption under the exponential distribution. What total randomness of arrival means the occurrence of an arrival of customer is not affected by the elapsed time length in between first and last event. The first event is what? The first event is at T1. The first event is here at T1. The first event is this one. Though in the Hamditaha, they say this is the last event. They are saying like this, that T1 is here, T1 is here, and so forth, so on. We are moving the last one in which we are interested. This Tn is the last one. This Tn is the last one in which we are going to. Tn means here is the nth event. Here is the nth event. T1 means here is the first event. But I would like to mention once more that this T1 they have considered the last one. And this is they have not mentioned, but here is the present one. Here is the present one. Here is the last one. But they assume that the desirous event, this is the desirous event. We are desiring this event means the last event. We are considering the last. This is last but one, n minus 1, then n minus 2, tn minus here tn minus 1, and Tn. This is the Tn. So just to look at this very point, this very point, okay, please look at this. Here, talking about the P, T is greater than Tn, Tn minus 1 plus T1 all the time, this is the total length of it. Given that the T is greater than Tn minus 1, Tn minus 2, and Tn minus 1. Because you cannot say that this T is not greater than, this is a precondition, this is provided that or given that, we will receive in mathematics, given that means this happens. This happens mean when we start, you look at, now look at this property. So this property of the probability says, we have already proved this one if you remember, but I am clarifying it. This probability is T is greater than Tn. T is greater than Tn means it does not talk about the length of the time which is considered this length of the time. This length of the time. And this length of the time is what? You just look at this part. Look at this part. I take the example then. I talk about n is equal to 4. Okay, a particular case, n is up to us to fix. So T1, T2, T3, and T4. We have T1, T2, T3, T4. The first arrival occurs at 10:20 am, that is the T1. This is the first arrival. Second arrival occurs at T2 at 10:27. The third arrival occurs at T3, that is the 10:30 am. And fourth arrival, 10:40 am, this T2 means fourth arrival. We will estimate the probability, or we would like to probabilize the occurrence of this desired event. Means I'm saying what would be the probability of arrival that will occur by the time 10:40. We are interested by the time 10:40, what will be by the time T4, because already up to 3 we have defined the time. So by the time T4 means by 10:40. What would be probability of occurrence of that arrival or occurrence of an event? 10:40. So this is T4. So we are interested what Tn means. Here is the T4. If you put here the probability that the event will occur by the time, this is not by the time. By the time is a concept of the no arrival. So you understand this point. I am coming to that one. This is fourth one. So you look at here T3, T2, T1. Here T4, T3, T2, T1 means all the time duration. This means total length. And total length is here what? 10 minutes. If you look at the beginning and last, this total length of the time is 10 minutes. So we are interested means probability after when this will be reversed. So this will be 1 minus less than equal to 10:40. T is greater than 10 minutes. So this we talk about the probability means that this 10 minute This is 10 minutes. I mean, when you started from 20 and this is 30. So this is again duration is 10 minutes. Per chance this is 30 and 40, you can say, but this may differ. So this total length of the time, the probability t is greater than t4, means we are not interested in the probability of an arrival which is going to occur by the time t is equal to t4 is equal to 10. So this means whatever time here elapsed, total time, we are not interested in this total time. We are interested in time after the T4, means we are not interested in time before the T4. I mean to say this. So this is the total time which is elapsed in between this first event and the last event. Last event is T3 at point T3, means this is third event, this is last event, and this is the desirous event. This is the at T is equal to the fourth event. We are interested in the fourth event. So this time elapsed is not important for us. This property is known as the property of, what property is the property of forgetfulness. This is the, that is the forgetfulness. And I also told you this is a property of nothing succeeds like success. So we are not interested. Suppose in the year 2020, I have got this success, then we are not interested prior time or before time of the 20, what struggles or what events in our life have happened. We are not interested. We are interested only the prominent event, the very shining event which has occurred in 2020. That's all. So this is the forgetfulness. Another property which I would like to explain today is this one. Probability of no arrival or zero arrival during time interval t. What does it mean? This is very frequently used topic, very frequently. Okay, we define it by, how we define it? You look at, we define it by the P naught t or P0t or no error. P0t means this is the time interval t. Means probability that no arrival during interval t. Okay. It is very oftenly written, this very point is very important, which I would like to make you clear. This point. This point. Inter-arrival time is greater than t. T is what? T is the time duration in which we are going to interpret the occurrence of the arrival. This is T. Okay, for this we define T as, we define the T as T2 minus, this is minus this PDF it was prepared in hurried manner, and therefore this quality is not. So this is T2 minus T1 is the interval T. Or if you want to write, you can also write the delta. But interval T is more oftenly used as compared to delta T. Now suppose, I think this point is clear, interval T, or we talk about the during interval. This is the during interval T. Suppose, now coming to another concept. Suppose, example. Suppose this T1 is equal to 10:30 and T2 is equal to 10:40. T1 is 10:30 am and T2 is 10:40 am. Then interval is 10 minutes. So I am talking about this very interval T, which is very frequently written in the mathematical derivation. Further, we define the interarrival time. How we define and interpret the interarrival time? Because interarrival time is greater than interval T. What does it mean? I have mentioned it T1 dash 10:30 am, T2 dash is 10:50 am. Okay, then interarrival time is equal to T2 dash minus T1 dash. That is how much?
20
this
minutes.
is the 20 minutes. This time is 20 minutes. This time is 20 minutes. This time is 20 minutes. Means this is what? This is the interarrival time, 20 minutes. And what is the time interval? This is the 10 minutes. Look at. When we say the probability, you just look at, probability of interarrival time is greater than interval T. What does it mean? Interarrival time greater than time interval T. Means 20 minutes is greater than 10 minutes. So this is interarrival time and this is the time interval. What does it mean? What does it mean? This means that this means that if any arrival occurs in interarrival time, any arrival, we are though interested in no arrival. I am saying this statement is very important. If any arrival occurs in interarrival time, because interarrival time is well defined, and interval time T is also well defined. You can put it capital T if you want, interarrival time, or whatever it is, or T dash, whatever it is, it will occur. You look at here, this point is very, it will occur. It will means event will occur. Event means arrival will occur. It will occur after 10 minutes. 10 minutes is the duration, small t. You look at here, 10 minutes. But within 10 minutes, no any arrival is going to occur or going to take place. If any arrival occurs, that will occur after duration t. After duration t, because after duration t, this is the interval, small interval t, up to here no any occurrence, because no occurrence in t. We are interested no occurrence in t. But inter-arrival time, if we want to put the rider, if we want to put the condition on the inter-arrival time and the interval t, we have one and only one option, only one choice, that is the inter-arrival time must be greater than the interval t. Because this is the inter-arrival time, means here arrival is going to happen. It is the inter-arrival time. Here the arrival has to occur, may not and may occur. So there are two options here, may not and may occur. But strictly within 10 minutes of the interval, there is no arrival. We are interested the probability of this condition. And therefore, it is necessary to make the inter-arrival time always greater than the time interval t. And therefore, in any definition, if you look at here, then the basic definition, this basic definition is laid down, and we start here this way. I also explained this very point through the book of Taha. This condition, if you remember, this condition is very important. And from here, if you remember the last lecture, then you will find this condition again, the fundamental condition. This part is very, very fundamental. And from here, we define it. If you just, if I am able to share another one, you can say something like asking, normalize. Here is one option, that share something else. Let us try. Share something else. It is not explain opportunity libraries. Stop sharing all this. So let us finish this discussion. Let us make the queries if possible. Then I just try to open another one, another this discussion. So I think is it clear what is the total randomness? Completely randomness. And if you remember, Deepak, you can open the you can unmute all. Let us have 5 minutes discussion. If somebody is making an query, then we can go ahead.
यस सर, सर यहाँ से नहीं होगा अनम्यूट, सब लोग अपना कर सकते हैं, खुद ही कर सकते हैं सर.
हाँ, okay, then we can chat. Where is my chat option? Chat is here. We can chat chat in the way. Here is the option of chatting is here, this one. So
Yes, sir.
Sandeep is saying yes. Any doubts? Any doubts? Ask is anyone. any one can have discussion. So this is the concept of the elapsed time. Elapsed time means from very beginning up to last, except the desirous event or point of the time in which we are interested. That is the desirous one. And this elapsed time, why this is important? And if you look at the application of the exponential distribution, exponential distribution has the fundamental assumption that it does not consider the elapsed length of the time in between the first and the last one, and therefore it is the exponential distribution which is applied and recommended for the application in queuing theory. You will ask why? Because we have also made one fundamental assumption that the inter arrivals are
independent.
independent.
Totally. Yes.
Yes, totally independent. Inter arrivals as well as inter arrival times are totally independent. Suppose you are not considering, you are considering, I mean, the elapsed length of time. So you will be interested in some previous events in previous arrivals. So the present arrival will be affected by the previous arrivals or previous time arrival times. So how you are random? You are not completely random. If I say, Deepak, you go there, after reaching you there, I will talk to you. No, these are the not independent events, because it is the conditional event. So if you make the condition arrival of anyone, then how you can make the assumptions that they are independent? If they are not independent, mathematically and statistically, we cannot recommend the exponential distribution as well as Poisson distribution for the queuing theory, though this may be a drawback of the exponential distribution whenever we talk about the reality of the situation. The reality of the situation may be that one event may be connected with another. Reality may be that if I start something, then and only then you will start. Reality, this may be. So reality, if you say this is the reality, then I say this is not completely random. So either you overlook the reality or you say the completely random. Both are not possible. So mathematics says that unless we have the fundamental assumption is what? Unless you believe in assumption, the mathematics won't go ahead. So assumption, you can say, is the fundamental things which we have to trust. And in mathematics, and this is like a shraddha in mathematics. If you say no, they are not independent, they are not, I mean, rivals are not, they are connected. They are connected, then we are not going to make any derivation, any of the derivation. The existence of the exponential distribution is not possible. So this is a compromise. And naturally, if you make the compromise, then you would get something. So these are the derivations which are possible. So this is the fundamental assumption which is made under the exponential distribution, and these are the situations which also occur in giving system as well as in giving model, and therefore we recommend the exponential distribution. So I think today is enough.
Yes, sir.
Today is enough. I will continue tomorrow. Now then pure model. Now things will be clear. This is mathematics. So tomorrow I will show more mathematical clarity, so that your derivation of any model won't face any difficulty in mathematical derivations, mathematical interpretations. And whenever you try to derive, whenever try to remember any step, you can easily reach there. So thank you very much today. If you want to make any doubts,